Hello everyone. So in this tutorial, we are gonna see invert binary tree, this problem of lead code. Okay. In this problem, you are given a function to complete, invert tree, and where you are given the address to the root of the tree. Fine. Okay. After inversion, however my tree looks like, I am to return its root. That's given the question inside the question. Fine. So yeah, you can see in example one that 4271369. Okay. That's given as my initial tree, and after inversion, it looks like 4729631. Right. How is it happening? Let's visualize a little bit. So yeah, let's have a tree here given in the example one. Okay. And after inversion, how it looks like 4729631. Right. Okay. So let's have a few observations here. So okay, this 4 is my root, right? Root of the entire tree, and that doesn't change its place. 4 remains intact, right? Now let's have a look on its left subtree. So 2, 1, 3 are the contents of left subtree of 4, right? Okay. Where is it going? After inversion, all the contents 2, 3, 1, everything is shifting to the right subtree of 4. Am I right? Okay. Similarly, what you can observe, all the contents of the right subtree of 4, okay, 7, 6, and 9. Where they are shifting, they are just going to the left subtree. Similarly, right? How to achieve this now? Do you have any idea? How should I achieve this? I have to shift whatever are the contents of left subtree of 4. They should be going to the right subtree, and right subtree should be going to the left subtree. The content should be exchanged. How to achieve this? Let's see that. So let me draw the tree here. 4271369. Correct? Okay. Now see, these are the pointers. 4 is having left child pointed to 2 and right child pointed to 7. Let me cut them. Now what is happening? After cutting these two pointers, the root of the tree 4, 2, 1, 3, the entire left subtree of 4 and 7, 6, 9, they are getting isolated. Now we have 3 isolated entities, right? Now what I will do, the right subtree pointer, okay, whatever 4 was having, I will shift it to 2, okay. The right child pointer 4 was initially having, I will just shift it to 2, and I will shift the left child pointer to 7, okay. Right child goes to 2 and left child goes to 7. What will happen next? Let us visualize. 4 is having 7 as its left child, and all the contents now arrive, whatever content 7 was having under it, okay. It now comes as the left subtree of 4. And similarly, what we can see is that now since 2 is the right child of 4, 2, 1, 3 will come inside the zone of right subtree of 4. We have achieved this. So far we have done this. Fine. What is left for us? Let us see that. Okay, till now, just the exchange of pointers we have done. I have drawn it here. Okay. What is our actual inverted tree? How it looks like? Okay, 4 is the root, 7, 2, 9, 6, 3, 1. Okay. Can I say? Just have a few observations. Okay. Okay. Can I say this is my left subtree, right? Current tree. This is my current tree I am having, current state of tree. Its left subtree is like this, and the left subtree that we are supposed to have after inversion, this looks something like this. How they are differing? Okay. Right now what we have 769, and how we should have it 796. Can I say this left subtree, whatever we have right now under 4, if I invert this, I can achieve this. Similarly, this 2, 1, 3, what we have right now, to achieve 2, 3, 1, a configuration like this, I have to invert this. Okay, I have to invert this. Okay, so at the end, after exchange of pointers, what we are left to do, to invert individually the left and right subtrees of my current tree. Okay. Okay. So let's write this relation somewhere. So what I can say, if suppose there is a function f that takes as an argument root of the tree, and this function is responsible for inverting my tree. Okay. This is responsible for inverting the tree. So what we have done, how to solve this problem? First, exchange the left and right child pointers, right? Exchange the first exchange operation on left and right child pointers. Okay. Along with that, what I require to do, tell me. Inverting the left subtree. Okay. I am providing the root here. So if I am to invert, what function can I use? Same function, am I right? This entire function inverts a tree, right? If suppose I am having this as my tree, 4 2 7 1 3. Okay. Let us write the change state of tree. Okay, what we have achieved. 7 6 9 and 2 was here, 1 and 3 was here, right? So we are now left to individually invert these set of trees, right? This set of subtrees. These two individual entities, the left and right subtrees, now needs to be inverted. What are they? They are subtrees only, right? What kind of subtree? Binary trees only, right? They also follow the norms of binary tree, correct? So what I can say, if an entire binary tree can be inverted by this function f, so a subtree which is of same nature can again be inverted by the same function. And what I will be providing here, pointed to the left child, and for inverting the right subtree, I will be providing inside f pointed to the right child. Okay. Finally, what we can say, how, what about the relation we have achieved? So we achieved like this as per you. So can I say that I have successfully broken down an entire problem into smaller ones? This entire tree, bigger problem was there, right? Entire tree needs to be inverted. Now this has boiled down to, okay, after exchange of pointers, just invert these two left and right subtrees. Correct? So what I can say, I have achieved a recurrence here. I have achieved a recurrence here. And my entire problem is recursive in nature. Right? When do we say that? When we have a bigger problem like this, and that is indeed dependent upon smaller problems of same nature. Right? We say that, okay, we are going to a recurrence relation like this. Right? And whatever relation we have made, this is a recurrence relation, and the problem is recursive in nature. So let's try to go ahead with the code. Fine, let's go ahead. Okay, so firstly, one case needs to be handled is that if suppose the root's value is null, that means I don't have any node inside my current tree, I will return the root as it is. Nothing to do here, right? If a tree doesn't have any node, it cannot be inverted, or nothing to be done here. Fine. Next, we have what tasks are left for us to do. So let me share you something, that is this entire function returns tree node pointer, and its definition has been given to you here. Okay, let's, so what we are gonna do, let me have a tree node pointer temp. Okay, and inside it, let me first have the left child pointer's address. Okay, why I'm doing so? To exchange the pointer values. Now roots left will be storing whatever is the content inside, or whatever is the address of right child of my current root. Okay, and what I can say, roots right will be storing now whatever address we have right now stored inside temp. That was the initial address of left child pointer. Fine. Okay, so we have successfully done what? Exchanged our pointers values. Next, what we are left to do, just apply this function. Where to apply this? Over the first left subtree, let's say. So I have to give pointer to the left child of my current root. Given. Next, I have to invert the right subtree. So I will give address of right child of my current root. Okay. Both the inversions are done here, and what we are left to do after inverting everything, return whatever is the root of my current tree. That's all. Okay. Let me try running this. Okay. The first test case has been accepted. Let me try submitting this. And we can see that, okay, we have successfully achieved our problem. Okay. Let me show you this. Now I've taken the code here. So let's have a quick dry run of our code, what we have done. And let's say this is my tree, 1, 2, and 3. And this is rooted at 1. Fine. So my first function call starts from 1. Okay. What will happen? Okay, see. This one has an address. So this condition is false. Okay. Now what will happen? See, if it doesn't have any right child, then what we say? Its right child is rooted at null. Correct? What will happen? These two pointers exchange will be happening. Okay. So what will happen now? One will be rooted for its left child at null, and its right child will be now 2. So whatever are the contents of 2 under its subtree will be coming along with 2 inside the right subtree of 1. Okay. So 2 node comes here. Its left child was 3, so 3 comes here, right? Fine. Now what happens? We call for the inversion of left subtree of my current root. Okay. So my current root is 1. So its left subtree is rooted at where? Null. So if I call for inverting a subtree that is rooted at null, this condition hits. This condition hits and it returns null. It returns null. Done. Now what happens? It calls for inverting the right subtree that is rooted at 2. So my current function call stands here. Okay. At 2. Let me draw it somewhere. How my current tree is looking like, and this is where my current function call is standing. What will happen? Now again, 2 doesn't have any right child. That means the value of its right child pointer is null. What will happen? Exchange. First, these exchanges will be happening. Exchange of pointers. How it will be looking like? 1, 2, 3 comes here. Its left child is now rooted at null, right? It happens. Fine. So again, if I am standing at 2, I call for inverting the left subtree. It returns null. Why? Because left subtree is rooted at null. Now if I call for what? Inverting the right subtree that is rooted at 3, my function call stands here. Now see, it's both left and right child, right? Both left and right child of this are rooted at null. Correct? So if you call for exchange, nothing will happen. Nothing significant will happen. And once I call for inversion of both these subtrees, both of them return null. So no particular structural change comes from here, right? After calling from 3, no structural changes will be happening. So what my final tree will be looking like? 1, its right child is 2, its right child is 3. I hope we have successfully achieved the mirror image of our initial tree, 1, 2, 3, right? So this is how my code is working. Okay. Now see, if we have n nodes, none of the nodes we have traveled or we have traversed more than once, just once, right? So what we can say, we can achieve this problem using recursive method in big O of n time. Okay, that's all for this problem. I hope you like this video. If you like, please like, share, and subscribe. Thanks for your time.